Are you fond of the wildlife? A zoo. Yes, as I say this word, you'll suddenly remember your yesteryears and the time when you visited a zoo with your class, with your family. Maybe it was a trip, it was a picnic, it was an educational tour. You know, if it were not a zoo, so many species would have become extinct. Actually, zoo is a place of the innocent prisoners. So, with a wonderful reminder of your past days exploring the wildlife and your fondant years when you loved the giraffe, the monkey, the Royal Bengal tiger, and so many more, let us shift the focus to the topic of the day. It's the various chemical reactions of the biotransformation of drugs. Welcome all to Is Pharmacology Difficult podcast. I'm your host Dr. Radhika Vijay, MBBS MD Pharmacology, and this is the audio hub to get the best simplified basic tips, strategies, methods, and lots of ideas to learn better, understand better, and make your concepts crystal clear. If you really find and if there's a question hovering in your minds, is pharmacology difficult? Lend me your ears for a while and let in the magic of knowledge. Well, a drug primarily goes through two phases of the reaction. Let us talk about the details one by one of the two phases. The first comes the phase 1. Now this is known by a variety of names like the non-synthetic phase, the functionalization phase, and the degradative phase. So they can be phases, or it can be also known as the non-synthetic reactions, functionalization reactions, or the degradative reactions. Now why? Why do we have so many names for this? Well, I will give you a solid reason for each of the naming method. So let's know all about it. Phase 1, it is called because it is the primary pathway. The drug is chopped off, it is reduced to small, polar, maybe non-polar, chunks or metabolites. That's what you call scientifically. But the importance lies in how this is all done. It is done by adding a new functional reactive group. It can be a hydroxyl group, that is OH, carboxyl group, COOH or CHO, or ammonium group NH2, or sulfhydryl group. It can be SH also. So it all depends. The new metabolite can be active or inactive. It really depends. You can never predict it. Since no synthesis is occurring, so rather breaking of the main compound occurs, so it's right and very apt to call them non-synthetic and degradative reactions. Now mainly they are microsomal in nature and they are oxidation reduction reactions. Yes, they are redox reactions, and many a times hydrolysis reactions are also there. But please remember, few of the reactions may be non-microsomal too. Well, we'll do that all in detail part a little later. Now let's jump right into the phase 2 reactions. And yes, they also have multiple names like synthetic reactions, conjugation reactions, and let's get to know the basis of these multiple names. The first point to be noted is that the drug is attached to an endogenous substance. It can be a metabolite. The endogenous substance can be glucuronic acid, sulfuric acid, acetic acid, or amino acid. Now the metabolite that we obtain, it is mostly, please pay attention to the word I'm saying, most of the times. I'm not saying always. So that means there are exceptions. So most of the times it is inactive. Just take this point in consideration. And you know what? Exceptions always become questions. So let us dig them out first. Morphine has a glucuronide conjugate. Minoxidil also has a sulfate conjugate, and guess what? They are active. So you cannot always say that curiosity kills the cat. Actually, this time the cat got brightened up its hat, right? Okay. Now, other things to know here, they are microsomal, mitochondrial, cytoplasmic enzymes. They all catalyze these group of reactions most of the times. And the metabolite I told you is mostly inactive. It is polar, it is water soluble. Now comes the golden time. Understand nicely the phase 1 and the shift, etc. If the metabolite from phase 1 is sufficiently polar, the kidneys can excrete it sufficiently. But that's not the case all the times. That's not what happens. Many phase 1 metabolites are still too lipophilic to be excreted. When the drug already possesses a functional group, it is eligible for the conjugation. It easily and readily enters the phase 2. No phase 1 metabolism is required in this particular case. Did you get this? This is very important, okay? While other drugs, they actually gain a reactive functional group through the undergone process of the phase 1 metabolism, and that is a shift. You ought to really understand this. Let me give you a sort of a diagram for this particular whole explanation. Now, before I give you the flowchart or the audio diagram, let me tell you one more thing. There are exceptions. One of the exceptions is morphine 6-glucuronide, which is more potent than the morphine. I told you that metabolites form, they are less potent, but this one is an exception. Morphine 6-glucuronide is actually quite more potent. And then it is easily excreted out by the kidney or bile. Now, one more typical example I want to give you here, that is of the fast and the slow acetylators. The fast acetylators, they show a quick diminished response to the normal dosage of the drug because of the high rapid metabolism, and that is exactly opposite for the slow acetylators. So there are always exceptions. Conditions change, genetic metabolism, genetic atmosphere changes, and that all affects the drug final response. Did you get this? So you cannot predict actually. You have to observe, you have to be monitoring all the time, and you have to be in consideration of all the factors that affect these things. Got it? Now I'm going to give you the flow chart. The flow chart starts from the lipophilic drug. The arrow heads to the phase 1 reaction. Now the reactions, they can be redox, that is oxidation, reduction, hydrolysis, etc. All are polar reactions. And the drug obtained as a result of the phase 1, it may be activated, it may be unchanged, and most of the times it is inactivated. Okay? Now then the arrow heads to the phase 2. What finally leads to the formation of a conjugate product. It is mostly inactive and water soluble. Now what you have to really understand in mind is one of the arrows you can draw directly from the lipophilic drug to the phase 2. Yes, that is what you have to understand. That is the exact crux of all this metabolism story that I'm telling you. That is a shift actually. That few of the drugs, they don't need to actually go through the phase 1 reaction. They directly enter the phase 2. The reason I've already given to you. 'Tis the golden moment to say bye to another week, another big chapter of our lockdown diaries. I hope you all be blessed with a bunch of wishful weekend. For all the updates and latest episodes of my podcast, please visit www.ispharmacologydifficult.com, where you can also sign up for a free monthly e-newsletter of mine. It actually contains a lot of updates about the medical sciences, drug information updates, and my podcast updates also. You can follow me on different social media handles like Twitter, Insta, Facebook, and LinkedIn. They all are with the same name, is Pharmacology Difficult. If you are listening for the first time, do follow me whatever platform you are consuming this episode. Yes, don't even forget to subscribe also. Stay tuned. Do rate and review on iTunes, Apple Podcast. Stay safe, stay happy, stay enlightened. Thank you.